Hi everyone. Today we are going to discuss indeterminate forms. So first of all, we'll learn about what is indeterminate forms. So you know that certain rules to evaluate the limits, guys. Certain rules to evaluate the limit, but some limits cannot be solved by using these rules. So this type of limit is called as indeterminate forms. So I'm writing here. You know that the limits of any function can be solved using or can be evaluate evaluate using some rule, guys, using certain rule. But but some limit or some examples of limits of function cannot be here evaluate by these rule. So these limits or these type of limits are known as simply it is what it is indeterminate forms are known as it is indeterminate forms. Means there are some complicated example of limits we have to solve by using this rule, guys, by using this rule. Means that is what some limits are solved by using this rule, but some limits cannot be solved using these particular rules. So that type of limits are known as this is a indeterminate form. So this is advanced part of limit, guys. This is advanced parts of limits. So let me think about, or when you have to we are going to discuss here indeterminate forms. So how many indeterminate forms, let me discuss here. So let me start. How many indeterminate forms? So there are seven indeterminate forms, guys. Seven indeterminate forms. So the forms are very easy to understanding, guys. If you observe the numerator and denominator of this form, then you will have to getting it is very easy to understanding. So first indeterminate forms is known as 0 by 0 form. Second indeterminate form is known as infinity by infinity form. Now third one indeterminate form is 0 into infinity, guys. Fourth one indeterminate form is infinity minus infinity. Fifth one indeterminate forms, that is a 1 raised to infinity. Sixth one is called as that is a 0 raised to 0. And number seventh one indeterminate forms, so this is infinity raised to 0. So guys, you have to observe this. Only you have to observe what is a numerator and what is a denominator. Suppose numerator is 0 and denominator is 0, then it is called as 0 by 0 indeterminate form. So how many indeterminate forms are there? So there are 7 indeterminate forms. So these are indeterminate forms, means these are limit. These can be solved by using L'Hospital rule, guys. So these limits solved by using L'Hospital rule, guys. L'Hospital rule. So these limits can be solved by using L'Hospital rule. So what is L'Hospital rule? So let me check here. Suppose you have to indeterminate form, you have to obtain 0 by 0. So how it obtain 0 by 0? Suppose let for example I am taking f of x is equal to, that is a sin x upon x, guys. Sin x upon x, that is f of x, and I wanted to take the limit. I wanted to take the limit of this function. So I want to take the limit as, guys, x tends to 0. X tends to 0 of f of x, so that is equal to limit as x tends to 0, means we are to taking limit on both sides, that is a sin x upon x. Now immediately you have to operate the limit on this function, guys. Means limit as x tends to 0 means here we have to replace x by 0. So sin 0 upon 0 means x is replaced as 0. So what will get sin 0? Sin 0 is 0 divided by 0. So you will get, this is indeterminate form, guys. 0 by 0, this is indeterminate forms. Also, for example, suppose you have taking the limits of this f of x as limit as x tends to infinity, guys. X tends to infinity of f of x. So limit as x tends to infinity of Sin x upon x. So you have to replace x, you have to replace x by infinity. So what you will have to getting infinity by infinity. So you will have to get the second indeterminate form, guys. So in this way, when you solving these limits, so you will get this type of 0 by 0, infinity by infinity. These are the forms. So for that you have to evaluate, there are certain rules, and there are some rules are there to evaluate the indeterminate form, guys. So all these types can be evaluated by using L'Hospital rule. L'Hospital rule means all these types of answer can be find out by using L'Hospital rule, guys. Now let me start L'Hospital rule. So what is the L'Hospital rule, guys? Means your function is given as, suppose your function is given as let f of x upon g of x. I am taking here the function. I am taking here the function, and I want to take its limit as x tends to here a, and limit as x tends to a. Then what will becomes as a limit x tends to a of f of x. I am separating the limit as in numerator and denominator. Limit x tends to a of g of x. If it satisfies 0 by 0, if it satisfies 0 by 0, then you have to use the L'Hospital rule. Also, if it satisfy, if limit taken as x tends to infinity, it is also satisfy infinity by infinity form. So these are the indeterminate forms, guys. These are the indeterminate forms. And if this satisfies 0 by 0 or infinity by infinity, then we use L'Hospital rule. Are you understand this? When we use L'Hospital rule, if 0 by 0 or infinity by infinity is form is there, then we use L'Hospital rule. But now actual question in your mind as it is, so what is the L'Hospital rule, guys? Now let me discuss here what is L'Hospital rule. Let's see. So L'Hospital rule, it is about the differentiation, guys. It is about the differentiation, guys. L'Hospital rule, it is about the differentiation. Now what is statement of L'Hospital rule? I am explaining here what is statement of L'Hospital rule, guys. So if I am taking some function here f of x and here g of x, if f of x and g of x be two functions of x, means I am writing are two functions of x, are two functions of x which can be expanded, which can be expanded by Taylor series, guys. You know the Taylor series. In expansion of a function, we have discussed this Taylor series, guys, by Taylor series. In the neighborhood of, in the neighborhood of x is equal to a, guys. In the neighborhood of x is equal to a, and if if limit as x tends to a, f of x that is equal to 0, that is equal to 0, means how it will be take the 0, guys. How it will be take the 0 means I am writing here once again, I am writing here once again. And if suppose limit as first function, limit as x tends to a, f of x, that can be evaluated by, so limit as x tends to a, f of x means it is what, x is replaced by only what is that, a, guys. X is replaced by what is that, a, means here we are to getting f of a, guys. And if this is a 0, right, this is 0 comma, also if limit as x tends to a, the function g of x, and you will have to also get g of a, and g of a you will have to also get 0, then we have to take limit as x tends to a, this function f of x upon g of x, this is equal to, this is taking limit as x tends to a, here f dash of x upon here g dash of x is there, upon here g dash of x. And this is called as L'Hospital rule, guys. This is called as L'Hospital rule. Means when we use the L'Hospital rule, if we have to operate limit on f of x and we have to operate limit on g of x, that limit is 0, then you will have to use here L'Hospital rule. So is called L'Hospital rule, guys. L'Hospital rule. I hope you have to understand this, what is L'Hospital rules. So there is one note is there, guys. We use Yale hospital rules when it get it indeterminate form 0 by 0 and infinity by infinity are the indeterminate forms, then then we use Yale hospital rule, guys. Yale hospital rule. Okay, means there is applicable for, means this indeterminate form, these are the applicable for Yale hospital rule. Otherwise the remaining indeterminate forms we cannot directly use the Yale hospital rule. So other indeterminate forms you have to convert first 0 by 0 or infinity by infinity indeterminate form, and then we use Yale hospital rule, and after that we have to solve this, guys. I hope you have to understand this, what is the Yale hospital rule. Now let me discuss about some example of indeterminate forms and which are solved by using Yale hospital rule. Now let me start some example. But before that we have to discuss some example. There are some standard limits are there. So let's see. I am discussing here some standard limits. Some standard limits, and these are very helpful for evaluating the limits, guys. So which are the standard limits? So number one, limit as x tends to here 0 sin x upon x that is equal to 1. Now these standard limits are also evaluated by using Yale hospital rule, guys. Because of that you have to check here, when x tends to 0, so sin 0 upon 0 it will get 0 by 0 form, and after that you have to use Yale hospital rule, you have to getting the result as 1. Now second, so limit as x tends to 0, tan x upon x that is also equal to 1. This can be also solved by using Yale hospital rule, guys. Number 3, limit as x tends to 0 sin inverse x upon x that should also equal to here 1. Number 4, limit as x tends to 0 tan inverse x upon x that is equal to, your answer will be, what is that, guys? 1 is there. Number 5th, limit as x tends to 0 sin hyperbolic h, guys, sin hyperbolic x upon x that should also equal to here 1 is their answer. Next, number 6, limit as x tends to here 0 a raised to x minus 1 upon x, a raised to x minus 1 upon x is equal to here simply log a, guys. Number 7, we have to use the standard limit also. So limit as x tends to here 0, so e to the power x minus 1 divided by x, so your answer should be log e, and log e, what is that here? Also 1 is there, so log e also will get 1. Next, number 8, we have to discuss here standard limit as x tends to here 0 1 plus x and bracket power here 1 divided by x, and your answer will be, what is that here? E, guys. And number 9, we discuss here limit as x tends to infinity, guys. Now here x tends to, what is that here? Infinity. Now limit is changes here, you have to observe and very carefully concentrate here. So limit as x tends to infinity, that is 1 plus 1 divided by x, guys, and bracket power here x, your answer should be, what is that? E, guys. Your answer should be, what is that? E. So when we have to getting the exponential e, if formula number 8 and formula number 9 is there, formula number 8 and formula number 9. So all of these standard results, so all of these standard result or these standard limits can be solved by using, not can be, this is directly solved by using Yale hospital rule, guys, by using Yale hospital rule. Because of that, all these limits satisfies the form, all these limits, all these limits satisfies this form as 0 by 0 or infinity by infinity. That's why we have to solve these 9 limit, means 1 to 9 limit, by using L'Hospital rule. I hope you have to understood these some standard limits are there. Now after that we discuss some example on limits, guys. Some example on limits means some example on indeterminate forms. So let me start example on indeterminate forms. Example on indeterminate forms. So type number first, guys. I am writing here type number first. Type first as 0 by 0 form. Type first as 0 by 0 form. So we have to solve problem under these types solved by using L'Hospital rule, and considering the fact I am writing here fact. What is the fact I am considering here? So that is L'Hospital rule, guys. That is L'Hospital rule. So let's see. Limit as x tends to here a f of x upon here g of x. You observe the numerator and denominator. That is equal to limit as x tends to a f dash of x upon g dash of x. So what is a f dash and what is g dash? That is f dash of x is a derivative of f of x, g dash of x is a derivative of g of x. And if we have to use this, if the limits are, means the limits as x tends to a of f of x, that is equal to 0, and also limit as x tends to a g of x, that is equal to also 0. Means when we have to check if fx, when we operate the limit on fx and operate the limit of on g of x, it will get the answer is 0. Then it will take 0 by 0 form, guys. Then it will take 0 by 0 form. And after that you have to use L'Hospital rule. After that you have to use L'Hospital rule. So for example, I'm discussing the problem number first, guys. So problem number first. So evaluate limit as x tends to here 0, right? X tends to 0, here 1 plus x bracket raised to n minus 1 divided by here x, and we have to evaluate this, guys. We have to evaluate this. So how to evaluate this? I'm taking the solution, guys. So what is the solution? So first you have to write the limit L as a given limit. So that is a procedure you have to find. So this is 1 plus x bracket power n minus 1 divided by x. Now you have to check what is a f of x and what is g of x, guys. F of x is a 1 plus x bracket raised to n minus 1, and g of x is the denominator function x. Now we have to check if we operate the limit as x tends to 0. So what will becomes limit takes the value, that is a 1 plus 0 bracket raised to n minus 1 divided by here x tends to here 0. So what is that here? 0 by 0 form you have to getting, and that is indeterminate forms. And if this is 0 by 0 form, then it is applicable for using L'Hospital rule, guys. Using L'Hospital rule means clearly you will have to getting here 0 by 0 form. So clearly you will have to getting here, what is that here? 0 by 0 form. And if you are to getting the 0 by 0 form, then you are eligible for by using L'Hospital rule. So therefore I am writing here by L'Hospital rule. So what says L'Hospital rule? You have to take just the derivative of this numerator and denominator, guys. Means L is equal to limit x tends to 0, take the derivative of the above terms derivative, means take the derivative of numerator and denominator. Denominator's derivative by default is 1 because x adds the derivative 1, and 1 plus x raised to n, its derivative is n into 1 plus x, and then 1 plus x derivative, it should be 1, and minus here 0. 1 derivative becomes 0 because 1 is a constant. So you have to evaluate this, guys. This is what is the remaining limit as x tends to 0. So into n in bracket 1 plus x and divided by 1. Now you have to also check further, is it 0 by 0 form or not? Further, is it 0 by 0 form or not? Now in denominator clearly 1, so that's why it is not 0 by 0 form. Therefore you are eligible for operate the limit directly. Means we have to operate the limit as x tends to 0. Means here when we are operating the limits, then it will get n in bracket here 1 plus 0. So what is your answer here? N. So therefore given limit that is equal to n, that is your answer. That is your answer. I hope you have to understand this problem number first. Let me start problem number second. So problem number second you have to solve here. Evaluate x into e to the power x minus log of 1 plus x divided by here x square. You have to evaluate this, guys. You have to evaluate this. Let's see how it will be evaluated. So I'm starting just here solution. So look at this example. Let given limit as L equals to, guys, given limit as I am taking L equals to what is that here? You have to operate the limit as, I am writing the limit as here x tends to here 0, guys. X tends to 0. So given limit as I am writing as it is, limit x tends to here 0. So what is that here? X into e to the power x minus log of here 1 plus x divided by here x square. Guys, you have to first check the numerator and denominator when we replace x as 0. When we replace x as 0. So clearly in numerator x into e to the power x, so we replace here x as 0, so it will be getting 0 minus log 1 is also 0 divided by 0. So it takes the form 0 by 0 form, guys. It takes the form 0 by 0. And if it takes the form 0 by 0, then you are eligible for using L'Hospital rule. So I am writing here applying L'Hospital rule, guys. L'Hospital rule. So we have to apply the L'Hospital rule as just you have to do here numerator and denominator. It's a derivative. You have to observe what is a numerator and denominator in given question. So you have to take its a derivative. So how to take its a derivative, guys? That is very simple or very much pretty easy to evaluate the derivative. So first one is x into e to the power x. This can be done by using product rule of derivative. So I am writing e to the power x as it is, and derivative of x is 1 plus next term is what is that x into derivative of e to the power x as it is e to the power x. Now this will be minus, that is log of 1 plus x derivative. It can be written as 1 upon 1 plus x, and 1 plus x derivative is again 1, and divided by denominator derivative means x square derivative, that will becomes 2x. Now guys, again you have to check, is it 0 by 0 form? I hope so. Is it also 0 by 0 form again? Means when we replace x as 0, again it will get 0 by 0 form. So that's why again applying L'Hospital rule is, till you don't get the 0 by 0 form, you have to just apply L'Hospital rule again and again. So again by LH rule, so L is equal to, so taking limit as x tends to 0. Again you have to take the derivative of the previous step, e to the power x derivative, e to the power x as it is, plus next derivative it is e to the power x plus x into e to the power x. Now this minus will be plus, and 1 upon 1 plus x square is the derivative of this term. 1 upon 1 plus x, it's the derivative 1 upon 1 plus x bracket square, 1 upon 1 plus x bracket square, and total divided by now 2x derivative. It becomes only 2 because x is derivative 1 and 2 is a constant. So it will get now here in this way the derivative when we apply the LH rule, guys. Now you check, is it not 0 by, or is it 0 by 0 form? You have to check this here. So clearly in denominator not x term is there, so that's why this is not 0 by 0 form. Therefore you have to apply directly limits, guys. Therefore you have to apply directly limits. Means limit you should apply here x tends to 0. So what is that here? E to the power 0 plus here also e to the power 0 plus x into e to the power 0 means here third term is 0 plus 1 divided by here, what is that, 1 plus x square, means remaining is what is that, 1 plus 0 and it's a square, and total divided by here 2. Now you have to just evaluate this, e to the power 0, then plus e to the power 0 means here 1 plus 1 plus, and last term will be also 1 and divided by 2. So therefore what is your given answer? L is equal to clearly 1 plus 1 plus 1, that is a 3 divided by 2, that is your answer. 3 divided by 2, this is your answer. I hope so you have to understand this very well. Next example I am going to discuss here, that is the problem number third. What is that? Evaluate limit as x tends to 1, x log x minus in bracket x minus 1 divided by here x minus 1 into log x. So solved by using the previous steps, guys, by using previous examples of steps, solving this. So how it will be solved? Let given limit taken as L is equal to, guys, given limit taken as L is equal to, and given limit is, what is that, limit as x tends to here 1, here x log x minus in bracket x minus 1 and divided by here x minus 1 into log x. So therefore limit is equal to, means L is equal to, you check guys, is it 0 by 0 form? So clearly you will have to getting it is 0 by 0 form, and if it is 0 by 0 form, you have to directly apply, what is that, you have to directly apply the L'Hospital rule, guys. So I am writing here applying L'Hospital rule, L'Hospital rule. So therefore you will have to getting L is equal to limit as x tends to 1. So when we applying L'Hospital rule, you have to take the derivative of numerator. Derivative of numerator, it becomes x into log x derivative, that will get 1 by x, right, plus log x as it is, and derivative of x is, what is that, 1, minus in bracket derivative of 1 minus or x minus 1, it will get here derivative of x only here 1, and minus 1 derivative, it will become 0 because constant derivative is 0. Again in denominator you check here, so log x as it is, and derivative of x minus 1 is 1 plus x minus 1 into log x derivative here 1 by x. So this will get cancel, x and x is here, and what will be the remaining in the next step? So L is equal to here limit x tends to 1, so 1 and minus 1, so numerator becomes only log x is there, and divided by here log x plus, I'm simplifying this or multiplying 1 by x in this bracket, so it will becomes x upon x is 1 minus here 1 by x. Because of that, it is very easy to take the derivative, guys, so that's why I'm multiplying this 1 by x in this bracket. So again you check, guys, again if we have to checking log x as a log 1, means x is replaced by 1, so log 1 answer will be 0, divided by also here you check as x tends to 1, that 1 minus 1 is again 0 and log 1 is again 0. So therefore this is again, guys, 0 by 0 form, this is again 0 by 0 form, and if this is again 0 by 0, again we have to apply L'Hospital rule. So therefore applying L'Hospital rule, again applying L'Hospital rule. So therefore L is equal to, given limit takes form as limit as x tends to 1, log x derivative here 1 by x, and total divided by log x derivative again 1 by x, plus 1 derivative is 0, and minus 1 by x derivative minus plus here 1 by x square, and now we have to check here again 0 by 0 form in numerator when we replace x as 1, so this is not 0 by 0 form, therefore we have to eligible for direct apply limits. So apply now directly limits here, as x tends to 1, so this will become 1 upon 1, so 1 upon 1 plus here 1 upon 1 square. So what is your answer is there? So answer you will have to getting here, that is in numerator 1 divided by in denominator 1 plus 1, that is equal to 2, and hence L is equal to 1 divided by 2, which is the required answer. I hope you have to understand this 0 by 0 form and these three example. Now, after this first type, we have to discuss the next type of indeterminate forms, means next types of example of indeterminate forms. Let me start type number second, guys. Let me start type number second. So what is the type second here? You have to discuss here, that is infinity by infinity, guys. Infinity by infinity, that is indeterminate forms. Example on, I am writing example on the type as a type number second, infinity by infinity, as this is indeterminate form. So in this type we have to solve infinity by infinity indeterminate forms. So we have to use L'Hospital rule, guys. L'Hospital rule, when your example takes or when your limit take infinity upon infinity, then we have to use the L'Hospital rule, guys. For example, let's see the problems under these types. The problems under this type are also solved by using L'Hospital rule. L'Hospital rule. So when we apply L'Hospital rule, now in this particular case, if you have to take limit as x tends to a, that is the L'Hospital rule I am taking here, upon f of x upon g of x, that can be written as a limit as x tends to a. Here f of x means f dash of x upon here again g dash of x. This is the L'Hospital rule. When we use here if limit as x tends to a of numerator means f of x, that is equal to infinity, and limit as x tends to a of denominator, that is means g of x, that is equal to also infinity, means your example takes infinity by infinity form, then this is eligible for using L'Hospital rule. It is the same as like 0 by 0 form, guys. It is the same as like 0 by 0 form. Now let me start some example on this type number second, infinity by infinity. Suppose I am taking the problem number first is here. Problem number first. So what is the problem number first? Evaluate the limit as x tends to infinity. In this type, in all example, guys, you have to given the limit as x tends to infinity. So what is that here? X tends to infinity log x upon here x raised to n. You observe what is f of x and what is the g of x, guys, right? So condition is also given where n is greater than, guys, here 0. N is greater than 0 means power is greater than 0. Then adjust the denominator, right? So let's see how it will be solved. So I am taking the solution is here. Let's see. So take given limit as L is equal to, so let I am taking the L is equal to the given limit, that is the limit as x tends to here now infinity, guys, and here log x upon what is that here x raised to n. You check, guys, is it now infinity by infinity form? Yes. Is it infinity by infinity? Yes, it is infinity by infinity indeterminate forms. Therefore applying L'Hospital rule. So I am writing here applying L'Hospital rule. In short form, I am writing here LH rule, applying LH rule. So what you will get here? L is equal to limit as x tends to what is that infinity. Take the derivative of numerator and denominator. Numerator derivative 1 by x, log x derivative 1 by x, and denominator derivative n into x raised to n minus 1. Now, guys, you have to now check, is it 0 by 0 form or is it infinity by infinity form? So yes, this is what 1 upon infinity, it becomes 0, and here also in denominator also that is infinity. So it is again infinity by infinity form. It is again infinity by infinity form. And if this is again infinity by infinity form, so therefore this is what, therefore we have to again applying L'Hospital rule. Therefore again applying L'Hospital rule. again by LH. So what we'll get guys here, so this is again taking the limit as x tends to here infinity. 1 by x is a derivative, it is a minus 1 upon x square, and divided by here n into x raised to n minus 1, it's again derivative here. How will you to take here? So this is 1 upon means already this is n into x raised to n minus 1, right? This is n into x raised to n minus 1, so it will becomes, what is that here, n into n minus 1 into x power now x n minus 2, x power n minus 2. So therefore it will get clearly L is equal to, that is 1 upon n, that limit as x tends to here infinity, 1 upon x raised to n is the remaining only, x raised to n, and therefore limit L is equal to, directly apply the limit as the limit L is equal to here 0. That is your answer. That is your answer. Now let me discuss the next problem here. Let me discuss the next problem. That is a problem number 2. Problem number 2. So let's see. Evaluate limit as x tends to 0 log sin x upon cot x, log sin x upon cot x. So let solution, how to write its a solution. Now it will be very easy guys, it will be very easy. Let's see. Let given limit as L is equal to, let given limit as L is equal to, that is what, limit x tends to here 0 log sin x upon here cot x, log sin x upon cot x, that is a given limit. You have to observe this. Now you have to check, when we apply the limit as x tends to 0, it will becomes infinity by infinity form. You have to check it guys, means x is replaced by 0, means here cot 0, it will get denominator is 0, that's why your form is infinity by infinity form guys. So therefore we have to apply L'Hospital rule. So therefore by L'Hospital rule, so by L'Hospital rule, L is equal to, what is that, you have to take the derivative of numerator and denominator. Log of sin x, derivative is 1 upon sin x into sin x derivative here is a cos x, divided by cot x derivative, it is a minus cosec square x is there. So by applying this L'Hospital rule, you will be able to getting this answer. So now you check guys, is it again 0 by 0 form or again infinity by infinity form? So this is not infinity by infinity or 0 by 0 form, and you have to directly apply here, limit guys. You have to directly apply here limit. So therefore L is equal to, that is a limit as x tends to here 0, we have to apply here. So what we will get when we applying this, or I am just simplifying here again, that much very easy to understand here. Now you know that what is here cos x upon sin x, you know the reciprocal cosec square x is the reciprocal of what is that here sin x. So this is cos x upon sin x, and I am taking here the minus of cosec square x is the reciprocal of what is that here sin square x. So therefore limit as x tends to here 0, limit as x tends to 0, one sign it get cancelled here, and remaining is what is that here only minus of cos x into here sin x, minus of cos x into sin x. Now you have to just simplify this. Now here is not numerator and denominator is there, here is only numerator is given to you, and that is not perfectly 0 by 0 or infinity by infinity form. So therefore L is equal to, directly apply the limits here, x as 0, so your answer will be totally here 0, and this is required answer guys, this is required answer. I hope you have to understand this. Now again we have to discuss next problem, that is problem number 3. That is a problem number 3. So what is the problem number 3 guys? Let's see. Let you have to given evaluate limit as x tends to 0 log of, or log to the base here tan x is given to you, log to the base tan x into tan 2x, log to the base tan x into tan 2x guys. So let's see. how to write its solution, guys. So let given limit consider as L is equal to, L is a limit as x tends to here 0, that is a log of tan x, log of, or log to the base tan x of tan 2x, log to the base tan x of tan 2x. So just I'm using the logarithmic property, guys. This can be written as L is equal to, that is a limit as x tends to here 0, that is a log of here tan 2x upon here log of tan x. So you have to check, is it infinity by infinity form, guys? So I'm checking as when we replace x as 0, it will get infinity by infinity form, means tan 0, that is log infinity, and means infinity upon infinity form is there. So therefore this is equal to, this is applying L'Hospital rule. So I'm writing here, if you are to getting this infinity by infinity form, so I'm writing here applying L'Hospital rule, applying LH rule. So when we applying LH rule, what we will have to getting here? Here we have to getting numerator and denominator, it's a derivative. So log tan 2x, its derivative is what is that? 1 upon tan 2x into tan 2x derivative, it is a 2 sec square 2x is a derivative of numerator, divided by, in similarly way you have to take the derivative of denominator is again 1 upon tan x, and tan x derivative it is a sec square x is there, sec square x. So therefore I'm adjusting this only, guys, I'm adjusting this only. So therefore by taking adjustment, that is a limit as x tends to here 0, so tan x upon here x into sec square x divided by here tan 2x upon here 2x, I'm adjusting this only, into here sec cube x. So this is adjustment is there only, adjustment is there, and we use the result. What is the result is there we have to use, that is let which result you have to use. Therefore limit as x tends to here 0, tan x upon x, tan x upon x, you know the this result, your answer will be what is that? 1. Your answer will be what is that? 1. So therefore given limit L is equal to, when we apply the limit as x tends to 0, your answer is what is that? For that, here is a sec square x, and here also sec square x. So in numerator and denominator, sec square x get terms cancel, and that tan x upon tan 2x, when we applied the limit, means what will becomes here, limit as x tends to here 0, tan x upon x, and total divided by here also limit as x tends to here 0, tan 2x upon here 2x. Your answer will be, by using this result, your answer will be what is that? 1 is there. Therefore L is equal to 1, and this is required answer. This is a required answer. I hope you have to understand this indeterminate form very well. In this session, we discuss what is L'Hospital rule, what are the indeterminate forms, and we discuss in this session also type 1 and type 2 problems, that is 0 by 0 or infinity by infinity problem. Now next types we are discuss in next session, guys, or it is sufficient for today, guys. I hope you have to understand this session. Thank you.